Welcome to today's lecture on genetic algorithm. Now, as you all know that genetic algorithm is one of the meta-heuristic algorithm where we try to mimic the procedure of genetic mutation and crossover that happens when there are two different populations having a chance to mate, and when they mate, the trait of one population is transferred to another population, and then when the offspring is produced, that offspring has the characteristic of both the population and may have some new characteristic also based on the degree of mutation that has taken place. So, as I have said, that genetic algorithm is a such heuristic that is inspired by Charles Darwin's theory of natural evolution. So, this theory mimics that theory of Charles Darwin, natural evolution, or the way the genes are transferred from two different populations to a new population which have both the characteristic of these two populations and also may have some new population, new characteristics based on mutation. This transfer of the characteristic of both plus and minus is known as crossover, and the generation of a new characteristic is known as mutation. And as you can see that this offspring can have the characteristics of plus population and minus population, as well as some new characteristic that was generated from the mutation only. But it may not have some extremely diverse characteristic that is not present in this plus population and minus population, and also cannot be created by mutation. So, but it is said that the quality of plus and minus population and the quality of the offspring, here I have named it that N, these varies a lot, and generally the quality of parents of these two plus and minus population is not as good or not as advanced as the quality of offspring. So that is what is known as the survival of the fittest, and those qualities which have survived the selection was transferred into the offspring, and that is why the best qualities of both parents is transferred to offspring, as well as some new more better quality can be created in this offspring due to that mutation. So, as I've already said, the transfer of qualities from parents is executed by crossover, and the new quality is created by mutation. So all this entire procedure of natural evolution is mimicked by the genetic algorithm, and how it is mimicked, let us see. So they said that, so let us take an example. In that way it will be better, but before beginning the example, just remember that There will be a search space, that means a solution space. There will be a fitness code, that means any fitness function is used as fitness code. And genetic algorithm will work on three operators. One is selection operator, another one is crossover operator, another one is mutation operator. So in case of selection operator, which two genes of both the population will mate or will cross over, that depends upon the selection operator. Crossover operator is the meeting or the two best individuals selected at the time of selection is crossovered or crossed to generate a new population. This entire thing is known as crossover to create a new individual known as offspring. So, and yes, as I've said, some new characteristic can come. So to insert random genes to create new characteristic not available in both the parents, so that is ensured with the help of the mutation operator. So why it is done is, in nature it is done to maintain the diversity in the population, and in case of algorithms it is done to avoid premature convergence. So that means that error, minima or maxima, this type of error can be avoided by introduction of mutation operator. So let us take a example, and this example is that this is optimization problem, and the problem is like this: y is x plus y. Very simple random example I have taken. So your job is to maximize y, and the constraint is, or the criteria that need to be satisfied is, x and y will always be greater than 0. That means x and y is non-zero positive integer or real numbers. Okay, as it is not mentioned that whether x and y can take only integers or it can also take fractions, so you can say that this is both x and y can take real numbers. So how it is done? With the help of the optimization, with the help of genetic algorithm, how you can optimize this problem. So what happens is, in the first step, this 8 random variables are created for x. That means from this x can, or x is assigned 8 random numbers. 8 random numbers. And for y also we create 8 random numbers. And yes, it ensured or it satisfied this constraint. That means all these 8 numbers is more than 0 for both x and y. Okay. And after generating, actually what happened is, these numbers are arranged in the descending order. That means from max or highest value to minimum value. Suppose for example that x has these 8 numbers. Suppose 6, 4, 3, 2, 1, 7, 8, 9. And for y, suppose these are like this: 10, 12, 14, 15. Right? Now, after generating these 8 numbers for x and 8 numbers for y, they are arranged in descending order. That means highest to lowest. Now, why we have arranged this in the descending order? Because we have the objective is to maximize y. So if both x and y is large, y will also be large. So that is why the highest value in magnitude of x is arranged in the first place, and then it is arranged in such a manner that the highest number get the first rank. First rank is assigned to the highest number, and the last rank is assigned to the lowest number or minimum number. So as our objective is to maximize y, so we will always try to assign the maximum values to both x and y. If we do that, then only we will get a higher value for y. So this x and y's are arranged in a highest to lowest order, and you can see that the top, that is the top 4 numbers from x and top 4 number of y, top 4 x's, top 4 y. These are separated out and they are selected as the best values for this problem. Why they are selected as best value? Because our aim is to maximize y. So if I add or assign x and y larger numbers among the population, then we will get the larger y. So this is here the fitness function. The fitness function is this the top 4 in magnitude. If our aim was to minimize y, then we would have selected the lowest 4 numbers of x and y. Okay. If arranged in descending order, then we could have selected the lowest 4 numbers of x and 4 numbers of y, which will give us the minimum value of y. But now here our problem is to maximize, so we are selecting the top. We are only taking the top. So the fitness parameter or fitness function, but in this case is top 4. That means larger the magnitude, greater is the selection. So here the first 4 according to magnitude will be, which 4? This 9 will be of course highest in x, followed by 8, then 7, that is third highest, and then 4. So 9, 8, 7, 6 is the top 4 for x, and 19, 18, 17, 16 is the top 4 for y. Okay, so these are the 4 numbers for x, these are 4 numbers for y. Now what happened is, you see here it is that all the y's are in the descending order. So first 4 is selected as the better fit for the given problem. Now what happened is, they are the best solution that we know. That is top 4 of x and top 4 of y are the best solution. Now what will happen is, so what we'll do is, here we have in the top 4, what I say that the range is 6 to 9 for x and 16 to 19 for y, correct? For x it is 6 to 9, that means 6, 7, 8, 9, and y it is I think 16 to 19. So this is the best fit or best solution among the all 8 numbers, 8 solution. Correct. Now what we will do is, so within the 6 to 9 we will generate 8 more numbers, and from 16 to 19 we will generate 8 more numbers, and use this as the population for crossing over. How I will come now? So 6 to 9, let us say I can take this as 7.5, 8, 8.5 and 8.8, let us say. We can take also 9 because we have said that, we have not said that 6 and 9 cannot be taken. 6 and 9 can also be taken, but the 6 and 9 is already generated in the earlier generation. So here 8 is 8 need to be 8 number need to be selected. So let it be 7.4, 8.2, 8.1 and 7.3. So note this, that all these 8 numbers in the first iteration as well as second iteration or generation will be unique. They cannot be repeated. So 7.5, 7.4, 7.3, these all are unique numbers. So this is for your x, as you can see, and for y this can be within, this has to be 16, within 16 to 19. So let be 16.5, 17, 7.25. So none among these 8 must be same as each other. All these 8 must be unique. So that is why what happens, 16.17, 17.25, 18, 18. So you can take it as usual, whatever you want. So what I have taken within 6 to 9, I have taken 7.5, 8, 8.5, 8, 8, 8.8, 7.4, 8.2, 8.1, 7.3, all 8 unique numbers. And for 16 to 19, that is for y value, I have taken 16.5, 17, 17.25, 18, 18.5, 18.75, 18.15. So these 1, 2, 3, 4, 5, 6, 7, 7, I think one more number is required, so let it be 16.25. So 8 unique numbers. Now the same thing you will do, take the top 4. Okay, so here what will be the top 4? All in case of x, the top 4 will be 8.8, 8.5, 8.1, and for y it will be, let me see, 18.75, 18.5, 18.15 and 18. So this 4, this 4. So now what the interesting part will come. During the crossover, what will happen? The top 2 number of this x population will be exchanged with the third and fourth number of y population. So here the third and fourth is 18.15 and 18. So this and this will be extended with this and this. So let me explain it in a more better manner. So what will happen is, let me explain it with a very clear place. So this is the X population, this is the Y population. Now for X, this is 8.8, 8.8, 8.5, 8.2, 8.1. And for Y, it will be all 18s, I think. Yeah. So it is, let me see. Yes, it will be 18.75, 18.5, 18.15, and 18. 18.75. So what will happen during the crossover phase? That means this is the phase when a new population with new characteristics is created. So these two will be exchanged with these two. That means the population X will exchange its top two genes with the third and fourth gene of Y population. I will discuss about the analogy later on. Okay, now for now we have to note that these two, the first and second solution of X, or first and second member of X, will be exchanged with third and fourth member of Y. So the new population will be like this: 18.15, 18, 8.2, 8.1. And one more new population will be created due to this exchange: 18.75, 18.5. This will become 8.8 and 8.5. Okay. Now what happens? This is one population, new population. This is another new population. Now these are again fed to this. The members of this population A is now and B will be now fed to the maximization equation X plus Y. That means these all will be used for X and these all will be used for Y. And the value of Y will be noted and tested whether it is the value of Y is more than the value of Y of the previous iteration. And this iteration will continue. So how this iteration will be continued? You see, this A and B is now two new population, and now they have their own range also. This range has become 8.1 to 18.75. This range has become 8.5 to 18.75. This is 18.15. This is 18.75. So from that two new ranges, let it be R1 and R2. So you will again have to create 8 new numbers and 8 new numbers, random numbers. Again, the top 4, this is top 4, this is the list 4. This is the top 4, this is the bottom 4. So bottom 4 will be exchanged with top 4 of this, and bottom 4 of this population will be exchanged with top 4 of this. So again two new population will be created. And again it will be tested with Y, and again this will be goes on. Now one thing I have not taught correct is after this phase A and B crossover and testing with Y, only the, like for example, we can easily understood that Y will be maximum at this two values when X is 18.15 and Y is 18.75. Y will be maximum. and when x is 18 and y is 18.5, y will be maximum, compared to when x is 8.2 sorry, and y is 8.8, and x is 8.1 and y is 8.5. So this y for these two values will be much more compared to what these two values. So these two are the best solution or best fit solution, and the range I was talking about, or I was telling, sorry, not talking, it is telling about, will be between these two. That means for x it will be 18 to 18.15, for y it will be 18.5 to 18.75. So the new numbers will be generated from 18.15 to 18 to 18.15 for x, and 18.5 to 18.75 for y. Okay, so from this range, that will be R1 and R2, 8 new numbers will be generated, and from them the top 4 will be exchanged with the bottom 4 of y population, and top 4 of y population will be exchanged with the bottom 4 of x population. So top, bottom, top x, y bottom, another is top y, x bottom. So new population is created, again you test, again you take the top two members, and again you do this. So this will continues, and you see this top two, now some said top two, this the way I am taking this top two values after crossover, correct, the top two values after crossover. Here I say top, not this one, this range R1 and R2 is from the top two values of this earlier population. So this selection of the top two values of both the population and creating a new population from this is known as the mutation. And if you select the top two values only, then you have 4 numbers here for both A and B, then the percentage of mutation you are allowing is 50%. Are you getting my point? You have 4 number of members for A population and B population, new population, among which you are taking only the top 2. So 2 out of 4, that means 50%. So in case of mutation, you will use the term 50%. And if you would have selected only 1, or you would have selected 3 members, top 3 from this population, then your mutation would have been 75%. But it is always better, based on the law of average, always take 50% of the population as mutation or for mutation. So after mutation, you see completely new population can be generated. You see, completely new population can be generated, because first we are generating any numbers for x and y which will be not 0 and positive. After then we selected the top 4, right? And after selecting the top 4, we have exchanged the members of x and y among each other. So top 2 has gone to as bottom 2 of y, and top 2 of y has been exchanged with the bottom 2 of the x. So after then, this is crossover, okay. But when after then you are taking the top 2 members of both the population after crossover, then that is known as mutation. So, as you can see from the procedure of genetic algorithm, you can see that first it is selection, then it is crossover, and then it is mutation. So, and all these numbers that is randomly created is same as genes of chromosomes. So, for the analogy I will come later on, but let me first explain the procedure. So, let us repeat it with this in context. Selection. What happens in the selection phase? So, this you understood that there is three phases in a genetic algorithm methodology. First phase is selection, second phase is crossover, third phase is mutation. So, what is the selection phase? So, our problem was you have to maximize y. These are two design variables, that means you can change x and y, provided both x and y will be non-zero positive number. Okay, so this non-zero positive number, you have to select your number from this. So, with the help of that, what we have done is we have taken 8 random values for x and 8 random values for y, and we have tested by assigning the values of x's in x of the equation and assigning the value of y's in the y of the equation, and then accordingly this y, this capital Y, it has its value from x plus y, and from that the top 4 numbers which has given you the highest 4 values of y, because our problem was to maximize y, correct? So to maximize y, the top 4 or the top 4 values of y after entering these 8 values of x and 8 values of y into the equation, it was noted and the corresponding x's and y's are selected. So you just note, but just concentrate on the term selected. How it is selected? How the number of values for x is selected? We have selected only those 4 values which has generated the highest 4 values of y. So this top 4 or highest 4 values of y is the fitness function or the criteria for selection. And so this is the selection phase where we have selected the top 4 values of x and top 4 values of y. So this ends the selection phase. Second phase will begin crossover. So here also, first we have arranged these top 4 numbers in the descending order. That means highest will be first rank and lowest will be last rank for both x and y. So for both x and y, we have arranged the 4 values which we have selected in the previous phase from descending order to in the descending order from highest to lowest value. Now in case of crossover, what is happening is, as I have discussed already, top 2 values of x is exchanged with bottom 2 values of y, and top 2 values of y, this is x as well. Now top 2 values of y is exchanged with bottom 2 values of x. Don't be confused. Top 2 of x with bottom 2 of y, top 2 of y with bottom 2 of x. So a new population is created, crossover phase completes. Now what happens? These, after exchanging, you get two new population, I think, right? Again you will get two new population, and this two population is that means in total eight numbers, correct? Let's see this one. Correct. So not eight, fourth set of numbers you have got. So now you enter the first value of x and first value of y. So you get a new big Y. Again, first value of x, second value of x, second value of y. You get a new value of y, big Y. Place the third placed and fourth placed, and you get a new value of big Y for both the cases, third and fourth also. As the equation is very simple here, y is equal to x plus y, you can easily understood that these top two values of x and y, these two, will give you the best two values of big Y, correct? Because x plus y addition, so it will always give the highest value of y compared to all these four, compared to the remaining two values. So after then what happens? The crossover phase is completed now. Then the next phase is mutation phase, and here what happens? Among these four values, we know that these two values have yielded the best values of our capital Y. So from this range, that means 18 to 18.15, again arranged in descending order, the top two only, not top four, top two. So we have arranged them in descending order, and now what happens? This is the 18.15 and 18 for x, 18.75 and 18.5 for y. So within this 18 to 18.15, eight new values of x is generated, and within this 18.5 to 18.75, that is for y, new 8 numbers for y is generated, correct? So this is, is known as the mutation, where the best fit population or best fit solutions are separated out from that crossover solution, and a new population is created which are better than that population, crossover population, such that new characteristics can be embedded here. So from that, there also from that 8 numbers, they are arranged in the descending order, and this top 4 here, top 4 will be exchanged with top 4 of x will be exchanged with bottom 4 of y, and bottom 4 of x will be exchanged with top 4 of y. Here you see, I already shown. Right, so to create a new population which is of course better than the crossover population, and this new population, when this procedure of generating another new population is known as mutation. And if you are selecting the top 2 here, top 2 from the crossover population, so 50% mutation will take. You can take also 25%, or you can take 75%. But generally 100% is not preferred, because then the entire population is used for crossing over. So in this way, the values of y is generated from this new population also, and it is noted, and among that the best value of y is also noted, that is the maximum value of y with the best value in this case, and corresponding x and y is also noted as the best solution. Okay, so this is the entire procedure of genetic algorithm, And there are various version of genetic algorithm. So some take it, some prefer this crossing over. Some say that no crossing over is required. Just randomly goes on generating eight random numbers for x and y, and test y. Again, if once you test it, take only the top value, and then or top two values, and then you create new eight values. Again test, and so on. So this is also practiced. But the main for all type of variation or versions of genetic algorithm, there will be a selection phase, there will be a crossover phase, because if this crossover phase is not there, new population will you will be unable to create new population. If this exchange is not taking place, top 2 with bottom 2 and bottom 2 with top 2, then there is no chance of getting new values of selection. So this crossover phase is mandatory, selection phase is mandatory, but the mutation phase is optional. If you are not satisfied with the values of objective number, that is y in this case, then you can move to mutation or with the expectation that some more optimal values can be generated. So this mutation you can do. But if you are satisfied with the values of crossover, then these two phases are. And if you are not satisfied with this crossover, then only you go for mutation. Now let us see what are the analogy. Okay, very important thing, analogy. So what is the analogy? Analogy means what is the analogy between the natural evolution and our genetic algorithm. In case of natural evolution also, there was a selection phase, there is a crossover phase, and there is also a mutation phase. So here what I mean is, whatever numbers you are, and this natural evolution says that there will be a search phase from where you can get the solutions. So the search space is the total characteristic or different types of characteristic in total of plus and minus, that means two parents. This search space is actually the total number of characteristics that the parent possesses. Because this, if I say this is P plus and this is P minus, and they have suppose 100 characters, and this P minus is also has some 100 characters, so your total search space will be 200 characters. That means within these 200 characters, the offspring that will be generated from this P plus and P point can have the character which is here within these 200 characters. Okay, so it may be mixed, but it cannot be totally new from this 200 number of characters, at least during the crossover phase. So, and what is the search space here? That constraint x and y is greater than 0 is the search space. That means it is saying that you can have x as non-zero positive. You can have y as non-zero positives, correct? Numbers. But you cannot have 0 positive or 0 positive or non-zero negatives. So they have identified the search space, And now what you will do is you will generate 8 random characters from X and Y within the subspace, and based on a fitness function you will select the best from both father and mother, and you will produce the crossover phase with that exchange. You know that from this 8, top 4 will be exchanged with bottom 4, and bottom 4 will be exchanged with top 4. So crossing over has been done. So father's character is transferred into mother's characters, mother's character is transferred to father characters, and 2 new set of numbers has been created. Right? 2 new set of numbers will be created. Okay. So this 2 new set of numbers will be tested for the best 4 numbers or top 4 numbers. So by testing with the help of that objective equation, top 4 is selected. So, and here also the top 4 will be selected. So among this top, again I have explained some error. So actually what happens when 8 numbers are selected, from here what happens, we are arranging these 8 numbers descending order. So highest 8 of X and highest 8 of Y is selected from this random 8. Correct? So yes, you will say it's selected. How it is selected? There is no selection here. So what happens is, this is the descending order, this is descending order. From this descending order, what happens is, what we are doing is, we are taking the best 4, right? Here you see what we have done. This is the 8 random numbers for X and 8 numbers random for Y. Among these, the top 4 was selected. This is top 4 for Y, and this is top 4 of X. And they are arranged in descending order, and from within the lowest to highest, what happens from lowest to highest? Yeah, 8.1 to 8.8, then 18 to 18.75. What happens? New 8 values are generated. That means what happens, from this random 8 numbers of X and random 8 numbers of Y, I have selected the best 4. Okay, and I have used these best 4, correct? I have used these best 4 that for generating the crossover population. But for generating the base of the crossover population. Then what happens is, from 4 I have C8 which is selected for crossover, and C8 which is selected for crossover. This is C8X, this is C8Y. So these 8 numbers are actually the selected numbers. So in analogy, these numbers that we are constantly generating from the search space are the genes. Okay, and you can say that what we are doing is these 8 numbers that we have generated in the first step. That means this one, when I am saying that randomly you will generate 8 numbers for X and 8 numbers of Y. So this is what, this 8 you can say that these are all what I say, the chromosomes. Okay, and within this 8, when we are selecting the 4, top 4, so those 4 can be analyzed with genes. 4 genes, 4 genes. So from these four genes, what happens? These four genes, what we are saying is we are creating eight genes for crossing over. And here you see, here also within these 8 genes we are taking only 4. So like that. What we are doing is from these 8 genes, what we are doing, we are exchanging characters. So the top 4 genes of X is exchanged with the bottom 4 genes of Y, and bottom 4 genes of Y X is exchanged with the top 4 genes of Y. So here the exchange of genes is happening, and exchange of genes is happening means crossing over is taking place. After crossing over, what happens is a new gene is formed, 2 new genes is formed, right? Gene 1 and gene 2. I have already discussed about this. I am just trying to, here you see. Here you see this is the 2 new genes. 2 new genes has formed. So among these 2 new genes, the best 2 genes are selected from A and B. Okay, but here in this step, the characteristic of father and mother has already been exchanged. Now we are selecting the best genes out of them. So with the base genes, what we are doing is we are again trying to generate a new set of genes, and we are again trying to exchange the characteristics of the new set of genes among each other to create a new population. Okay, so this is the basic of analogy. In case of selection phase, first we are randomly selecting. This is also selection. But when we are arranging in descending order, this is the optimal selection. And when after then, what we are doing is we are taking the top 4 from each and creating some new population. So where the characteristic of the top 4 is embedded. Then what we are doing, we are exchanging characters. That means among these top 4, from these top 4 optimal genes, we are creating 8 more optimal genes. So naturally, you can expect that the previous 4 will have less quality compared to the new 4. And then what is happening is we are taking the top 2 from this new gene, or after exchanging the father's gene and mother's genes with each other, we are getting the 2 new set of genes, G1 and G2, as I have indicated. We are taking 2 new set of genes, and this 2 new set of genes is now applied, okay, for selecting the more optimal set of population. That means you see these 2. So these are the optimal. Here the mutation is taking place. So from this new set of genes, what we are happening, we are creating again new 8 numbers of population, and again we are exchanging like the crossover. But here what we are doing is we are exchanging the characteristic of the new set of genes, not the older set of genes. So already the crossing over has taken place, but to insert some new characters which are completely different from the father and mother, we are doing this. Here the exchange of father and mother characters has taken place. After exchange, what is happening? This is new gene, this is new gene. So when I am taking this 4 like this, so we can expect that totally new population will be created from this. And then again we are exchanging, that means it will be more separate or more diverse population when we exchange that values among each other. Okay, so that is why this process is continued until and unless we get a satisfactory, or we get a target value of the objective, or we understood that when further maximization was not occurring, then also you can stop, because we understood that within that solution phase there is no further or no more optimal solution exists. But this is an infinite number process, so that is why when we are selecting maximization as the termination criteria, corresponding to that in, we also imbibe, or we also implement two more criteria, that is the time criteria and number of iteration criteria. So when the specific time is elapsed, the iteration will stop, or when the specific number of iteration is completed, the iterations will stop. Okay, so when I select this maximization, this is the thing. If you select the minimization without any target value, yes, there also you have to put some fixed time and fixed number of iteration, after which the iteration will be terminated. But in case of target, generally this is not required, because once the target is achieved, iteration is terminated automatically. But if there also, we generally indicate these two parameters, time and number of iteration. If target cannot be achieved within this time and within this number of iteration, then also termination takes place. So, in summary, what I can say is, in case of summary, is that you see what happened is, so in case of summary, I will say that in case of summary, I will say that yes, I'm repeating this. What we have done today is, our equation was like that, x plus y is big Y, and our problem is to maximize this value. And the condition or constraint was x and y must be non-zero positive number. So these small x and small y can be indicated or can be deployed as design variables, and y as objective variable. This is your constraint. So in case of genetic algorithm, this is a meta-heuristic algorithm. So we, at the first, we generated 8 random values of x which are non-zero positive, 8 random values of y which are non-zero positive, and we arrange these 8 numbers in descending order, because our problem is to maximize y. And in case of descending order, highest get the first rank, lowest get the lowest rank. And once this arrangement is completed, the next step, what was the next step? Next step was to, let me see that, the next step was to select the top 4 numbers among that population, and with the help of these top 4 numbers we can identify a range. That means top 4 from lowest to highest, top 4 of x, top 4 of y, lowest to highest, within that top 4 numbers. Again, this 8 random number is generated, correct? And they are arranged descending order. Now, what happens is, top 4, or what I have told here, Okay, so in case of crossing over, what happens? So y3, y4 is extended with x1 and x2, or you can exchange y1, y2 with x3 and x4. Any one you can do. So this new population will look like this: y3, y4, x3, x4, and this one is y1, y2, x1, x2. Okay, so you have two new set of population. So then again you assign the values of x and y as like this: y3, y1, y4, y2, x3, x1, x2, x2, like this. And then you get new set of big Y, and from there you select the top two solutions, that means maximum values of Y, first and second, and then that means it can be possible if I use this one only, because as you know this is X and this is Y, exchange crossed over. So these two will, so this ends the crossing over phase. Now what happens for mutating? What you are doing is, from this range you are generating 8 random, 8 random. In this case what we are doing is, from this 8 you are arranging it in descending order, and then you are exchanging. Okay, 4 top, as I have already explained, 4 top of X, 4 bottom of Y, or 4 top of Y and 4 bottom of X. So exchange. Okay, and with this you get again two new set of population which will have some diverse characteristics compared to its parents' characteristics. And then you again feed into this equation y equal to x plus y to get new values of the objective variable, more optimal values certainly, and so on. And after then you have to repeat until and unless you achieve your target, or you see that the values are not changing for a certain number of iterations or for a certain number of time. Then the iteration process is terminated, and the values with which the last optimal value for y is achieved is collected as the optimal solutions. Okay, the values for which the y has given the best values, or to be more precise, values of x and values of y for which this y has given the best solution among all the iterations. Those two values of x and y will be the optimal solution of this problem, at which y indeed has achieved the maximum value within its stipulated subspace. And what is this subspace? X and y must be greater than 0. So I think this process is now clear to all of you. And to remove confusion, you can say, like, you can arrange this procedure like this: selection, crossover, mutation, optimal solution. So the selection is random number generation. These numbers are also known as population. Okay, this is also known as population. Clear? And descending order is maximization problem, ascending order for minimization problem, and there is many other fitness function you can use. And then from here, whatever you have picked, top 4 will be fused, and the range of top 4 will be used for creating 8 new numbers. this top 4 is actually finishing the selection phase. After range of top 4, generation of 8 new number is a pre-phase or preparation of the next phase, crossover. And here you, as you can see, 8 new numbers is generated. From there also top 4, correct, in case of crossover. Top 4, top 4x, top 4y, exchange, again exchange. Okay, and then based on the optimal solution, you can easily select the top 2. Okay, and from this top 2 you get a range. And this is also means your crossover phase is finished here. Top 2 range is pre-phase to mutation phase, preparation phase we say. And in case of mutation phase, what happens? Yes, top 2 range, new, so new 8, exchange, okay. And with the help of exchange, you will get new population. Actually, 2 new population you will get. And 2 new population, then you again try to find this y, 3y, x plus y. And then you try to, as this is a maximization problem, you try to maximize it until until you get or you come into some number of iteration when for a certain time or number of iteration the values of y is not changing. Then at that moment you can say that y has reached its optimality, and at there the corresponding x and corresponding y is taken as the optimal solution of dv. That means if you execute this equation at these 2 values of x and y, then you can expect to get the best value of dy. That is what the objective of this entire problem. Okay, so this is overall the procedure of generic algorithm. And as you can see that for only 2 variables, x, small x and y, you see the procedure, so many steps. But these algorithms can be used when there are n number of variables, x, y, z and so on. And for then also there will be the same procedure, just multiplied by 8. Steps will be multiplied by 8. And in this case x can mix with y or z also, or z can mix with y and x also. So it is up to the developer of the algorithm. You can fix it or you can make it also random. That is up to you. So, but however, this generic algorithms, there are some strengths. Yes, they are robust. They provide optimization of a large state. That means they consider each and every solution possible within the subspace, and they have no initial point and final point. They can select it from anywhere randomly, any point of the subspace. They can select the solutions. And also you see they doesn't not require any derivative information. They are faster, more efficient, parallel, and they can optimize both continuous and discrete functions. That means continuous means x and y have the value from 1 to 4. Each and every value within 1 to 4 they can take. But if it's a discrete optimization, then x can vary from 1 to 4, where they can take only 1, 2, 3 and 4 as well. Okay, so this is discrete and continuous. And yes, this algorithm actually provides a set of good solutions, as you can see, top 4. So not just a single solution, there are a set of solutions. So, and you will always get the answer to the problem. And as I have said, yes, more the iteration, more better solution you can expect. But this is the most vital tip for you. As the search space is very large, so if and only if there is large number of variables there, you use genetic algorithm. But if you have a very small number of variables, that just like the example problem, only x and y, then avoid using this type of pseudo algorithm. Remember, genetic algorithm is also known as a pseudo algorithm. So it is not a total algorithm because it depends upon random numbers, random generation of numbers. So it is also doubtful whether the solution provided by them is optimal or not, because of the next iteration maybe a better solution can be. Okay, so that is why they are saying that this GA is not for all problems, only for those problems where you are not getting optimal solution after multiple number of iteration also. You are not getting a solution, then only you use GA. Because G is also known as the solver of or solver when no one can solve. Solver when no one can solve. That means after using all different types of algorithm, then also you are not getting your optimal solution. Then only you use this G. Otherwise, don't use G. And that is why they are saying that, which is simple problems, easy to achieve, easy to solve, and derivative information is available, don't use G. Okay. And as this fitness value is calculated at each iteration, the top 5, top 4, this top 5 is identified in each iteration. That is why it is computationally expensive. And this is the major problem is this is a stochastic because it depends upon random generation of numbers. Okay, and yes, if not implemented properly, the GA may not converge to the optimal solution. As I said, more you iterate, more new solution will be generated, and a better solution will be generated. Okay, so solution can be improved. Okay. However, when there is no way to solve something, use GA. GA will definitely solve your problem.